All right, finishing up our sequence and series, we move on to our geometric series. Now, arithmetic was produced by adding or subtracting, really adding positives or adding negatives. But geometric is going to be produced by multiplying. You can multiply either positives or negatives. And so in this case, we have 2 plus 4 plus 8 plus 16. You'll notice, whereas I could get to this but via a plus 2, now I'm getting to it via plus 4. You're like, wait a minute, that's not consistent. So if it's not being consistent, then it cannot be arithmetic, or at least not first generation arithmetic. Now on the other hand, we could get to it as times 2, times 2, times 2. Now we're being consistent, so we can clearly say that we're getting a difference of multiplying by 2 every time. Now, we can't really call it a difference because we're not subtracting. What we do is we call it a ratio. R equals 2 in this case. Now, the reason that we call it a ratio is because R equals, just like in arithmetic, we took any term minus the previous term. Well, in our case, we're now going to, since we're multiplying, the reverse of that is going to be divide. So any term divided by a previous term. All of those turn out to be 2. R equals 2. Now, in this case, you say, well, how do I move from here to here to here to here? You say, ooh, you're adding. You're adding because this is 1, that's 2, 2 more, 2 more. But wait a minute, how do you get exponents to increase? Well, what you're really doing is you're multiplying by w squared, w squared, w squared. And so by multiplying by each of those, we could verify this by saying w to the third divided by w equals w squared. R is clearly w squared. Now, you can also do it with something that's algebraic in nature. And with this one, we come up with, again, 9x plus 3 all over 3x plus 1. You cannot, do not cancel just things out because I have plus or minuses top and bottom. However, if I factor out 3, I have a 3x plus 1 in the top and a 3x plus 1 in the bottom. And so we end up with a difference of 3. So R equals 3. And let's see if that works. If I multiply everything by 3 here, do I get 27x plus 9? Yeah, so it works out. So the recursive form, remember recursive meaning to get from one to the other, is you take any term and you multiply it by the difference r, and that should give you the next term. So in our case, we said, hey, 2 times 2 equals 4. 4 times 2 equals 8, and so on and so forth. Now, if we want something explicit, okay, I want to get to the 27th term, something like that. What we're going to do is we're going to take a to sub n equals a sub 1 times r to the n minus 1. The reason we do this is because what we're really doing is up here we're multiplying by 2 once, by 2 twice, by 2 3 times. So 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, etc. Down here, w squared to the first, w squared again, w squared again, w squared again. And so all you're really doing is you're saying, what are you multiplying by? And it's going to be one less time than the number of terms. So if I want the 10th term for our first series, we have a sub 1 equals 2, and we're going to multiply that by 2, and if I want the 10th term, it's going to be to the 10 minus 1. And so I'm going to say 2 times 2 to the 9th, and whatever that is. It's a really large number. So we have that. That's using the recursive and the explicit. Now, moving on, we have the geometric means. We had a similar deal when we had arithmetic means. And that's when we added. Well, again, we can do the same thing, but in reverse. We can say, hey, I have the 4th term, so I have 625 equals 5 times r to the, now I know that this is the 4th term, so 4 minus 1, and so I can solve this problem for r. Now divide both sides by 5, I come up with 125 equals r cubed, and so then I cube root both sides, and 5 equals r, and so I multiply by 5, multiply by 5, multiply by 5. And it works out. Alternatively, previously we were able to take the top minus the bottom and then cut up the pieces. Well, you can kind of do the same thing again. You can say 625 divide by 5, since it's multiplication to get there. And that's going to equal 1, 2, 3 steps, so that's r cubed. But you'll notice it's not quite as intuitive as it was in the previous series where it was arithmetic. And so you come up with, again, r equals 5, and so you get 25 and 125. Okay. Now, just like last time, we were able to find the series itself, or the sequence itself. Once it is a sequence and we're adding numbers up, 8 plus 14 plus 24.5, we need a way to add up that series. Now, it's obvious that if it's 1, 2, 3, 4, 5, 6, you could just find the terms, add them up, not a big deal. But if I wanted, say, the 10th term, or in this case, 6th sum, I want to find the sum of the first 6 numbers. What I'm going to need to do is use this formula up here. Now, to find this formula, I need to find s sub 6 equals a sub 1, which I happen to know, parenthesis 1 minus, now we need to know the ratio. Well, to get the ratio, again, take any term, divide it by the term in front of it, and so we come up with 14 divided by 8 is 1.75. So 1.75 raised to the what power, be 6th in this case, all over 1 minus 1.75. If I work that problem out, that will give me the sum of the numbers that I need. You can do the math on that, it's not that challenging. Down here we have a small problem. Here we're looking for another summation, but we're not starting at the first term anymore. We're starting at the third and going to the 10th. Well, we can do a little bit of a trick. This formula up here works from any starting point. So instead of having a sub 1, which if you're smart, you can, and you have good recognition, you'll recognize, well, that's supposed to be a sub 1. That's supposed to be r, because that's the formula from right back here. But we are going to be starting at the third term, not the first term anymore. So let's just go ahead and find the third term. So I see 4 times 2 to the 3 minus 1, so that's squared, so I get 16 as my first term. Now, you could continue on and say, okay, 4 times 2 to the 4th minus 1, well, that's going to be cubed, that's 8, and that's going to be 32, plus dot, 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 all the way to the 10th. So you have plus dot, 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 plus 4 times 2 to the what amounts to 9th, because it's 10 minus 1. Just a second, we'll be right back. Now, I went ahead and found this as 2048. We want to add all these numbers up. To do that, I can simply say a sub 1. Well, let's just start here, since that's the first term in the series that I care about. Let's go and start at this one. So I have 16 times 1 minus, the ratio is still 2, but now how far is this away from this? Well, 10 minus 3 is 7. So it's 7 away, so we put 7 here instead of 10, because we're starting at 3 and going to 10 rather than starting at 1 and going to 10. 1 minus 2. If I put all of that together, then that will give me my total sum. Okay, real quickly, small correction to make. I did this to the 7th power. The problem is 3 to 10 is actually 8 terms. Because 3, 4, 5, 6, 7, 8, 9, 10. That's going to be 8 terms. So if I do that, I come up with 16 times 255, which is 4,080. So that's my total there. Now, that's finding partial sums. We now return to our convergent and divergent discussion. If I were to take anything arithmetic, add 2, add 2, add 2, subtract 3, subtract 3, subtract 3, add 5, add 5, add 5, you'll notice that the numbers themselves are getting bigger, 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 bigger. or smaller, 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 bigger, 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 bigger. So even if I were to begin adding these up, it's always going to get bigger, it's always going to get smaller. All arithmetic diverge. So you cannot add them up to infinity. You can only add them up to a certain level. Now, if we go down here to something that is geometric, I'm multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2, you'll notice it's going up again, so it's diverging again. So sometimes a geometric diverges. However, if I were to multiply by a half every time, 8, 4, 2, 1, 1 half, 1 fourth, the terms themselves do this. And they're going to converge. They're going to converge towards 0. But remember, that's the terms themselves. If I wanted to add them up, I start with 8, then I'm going to add 4 to it to 12, plus 2 more is 14, plus another one is 15, plus a half, plus a quarter. And you'll notice they go up, but they go up less and less and less and less and less. So the terms themselves converge to 0, but when you add them up, the sum converges to something else. And to find that sum as we go toward infinity, we have another little formula. It's the sum as it approaches infinity equals a sub 1 over 1 minus r. This comes from the fact that if I want to find a 2,000th sum, that would be a sub 1 times 1 minus 1 times 1 half to the 2,000th power, just like we saw previously, over 1 minus a half. But what is 1 half times 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 1 half? It's going to approach 0. So in essence, this section here goes away, and you have 1 over 1 minus a half. So you end up with, in our case, 8 over 1 minus 1 half, which is really going to be 8 divided by 1 half, which is 16. And that seems to be what we were approaching. So converge and diverge are very closely related. Here is the homework for this section. And you'll have to use the formulas that you saw previously in here. I highly recommend writing them down. That should give you enough time to hit pause. And here you go.